Welcome back to the Revit for MEP modular training series. In this video, we're moving into Module 9, Introducing Systems. Here, we'll establish the foundational logic behind how MEP systems behave inside Revit and why creating systems correctly is so important for sizing, analysis, and coordination. The purpose of this module is to introduce you to the core concepts behind MEP systems in Revit and to explore the rules and logic you need to follow when assigning components to the correct type of system. This module is presented as a lecture first, followed by a practical exercise. Throughout the lecture, we'll unpack terminology, system behaviors, and best practice workflows to help you create clean, analyzable, and coordinated systems. We'll look at how ductwork, pipework, electrical elements, and public health components all join together inside Revit to form intelligent systems. A key objective is understanding why systems matter, not just for connectivity, but also for load calculations, flow analysis, and system reporting. We'll also introduce the system browser, which is one of the most important diagnostic tools you'll use throughout your project. Although different systems, such as HVAC, electrical, and piping, each have specific tools and properties, many of the workflows are identical. So when we look at duct systems in this module, the same logic applies across all other domains. In a typical design workflow, spaces and zones are established first. Then demand elements like air terminals, lighting fixtures, or plumbing fixtures are placed. Once these are in place, you can begin creating systems that link all of these demand elements back to a supply source. In Revit, system types are broadly grouped into HVAC, electrical, piping, plumbing, and fire protection. The exercise at the end of this module will walk you through creating your own system using the dataset file WFPRME09 Systems A. During this module, we will cover the following learning objectives. Understanding the key considerations when setting up the project for MEP systems. Understanding the different system types and how they are used. Learning to use and customize the system browser for better control and troubleshooting. Exploring how connectors work inside families, and why connectors are the foundation of all MEP systems. And finally, looking at alternate air systems and understanding the variations available depending on the design approach. Setting up the project profile. Before you create any MEP system in Revit, you need to establish a proper project setup. Systems can be developed from initial design assumptions or, ideally, from room data sheets and space information. These typically include heating and cooling loads, supply and fresh air requirements, return and exhaust air volumes. Revit relies heavily on room-based information. If ceiling plans aren't provided, you may need to create reference planes or datum levels to assist in placing elements accurately. In this module, we also highlight an important principle. Even though Revit is intelligent, it's not magic. When creating MEP systems, you must follow certain steps carefully to ensure Revit can size and analyze the system properly. Examples include splitting duct or pipe elements before size changes, applying correct transitions, presetting duct conversions and loss coefficients. These allow Revit to generate the correct results based on your design assumptions. Main systems overview. In Revit, systems represent logical groupings of components. Assigning components into systems allows you to tag, report, filter, analyze, and size them. There are three major system categories. 1. Duct systems. 2. Piping systems. 3. Electrical systems. Duct systems. Duct systems meet airflow requirements and heating or cooling loads. Systems are created by placing air terminals and mechanical equipment, then using Revit's automatic system creation tools to route ducts. Piping systems. Piping systems are logical structures that enable Revit to calculate pressure, flow, and sizing. They are created by connecting piping to mechanical equipment, establishing supply and return systems. Layout tools help you explore routing alternatives. Electrical systems are created by placing lighting fixtures, devices, and electrical equipment. You can assign fixtures to specific switches, and switches operate independently from circuits. Unlike ducts or pipes, electrical containment is grouped by service type, not system type. The System Browser. The System Browser is located under the Analyze tab or the View tab in full Revit installations. It displays every system in a hierarchical structure, by discipline, by system, or by zone. The browser is fully bi-directional, meaning changes you make in the browser affect the model, and selections in the model highlight items in the browser. You can use it to find unassigned elements, diagnose gaps and missing components, inspect flows and loads, check system continuity, filter systems by discipline or name, and of course you can launch it instantly using the keyboard shortcut F9. Filters and visualization. Filters for systems. Filters are essential when working with MEP systems. They allow you to visually separate system types by color, pattern, or line style. For example, you could create a blue fill pattern for mechanical supply, green for mechanical return, red for fire protection. Filters can be based on service type, system type, classification, or any common parameter. This dramatically improves visibility and coordination within crowded service zones. Connectors. Connectors. The heart of Revit MEP. One of the biggest differences between Revit MEP and Revit architecture or structure is the presence of MEP connectors. Connectors allow components to behave intelligently, enabling calculations, establishing flow direction, and defining allowable system types. There are different connector types: duct connectors, pipe connectors, electrical connectors, cable tray connectors, conduit connectors. Choosing the correct connector discipline is absolutely critical. Once a connector is placed, its discipline cannot be changed without deleting and recreating it. Other air system types. Alternate air systems. Although our example uses a local fan coil unit system, other air systems include VAV systems with terminal controls, central air systems using reheaters and cooling coils for zone control. Each of these systems uses the same Revit logic, connectors, systems, and routing, but with different operational behavior. That concludes the theoretical portion of Module 9, Introducing Systems. We've explored the logic behind how MEP systems operate inside Revit, the importance of connectors, the role of the system browser, and how filters improve clarity and coordination. Next, we'll walk through the full hands-on exercise and create a complete mechanical supply air system step by step. In this exercise, we'll walk through the complete workflow of creating an air supply system in Revit. We'll place air terminals, add a fan coil unit, create the system, generate duct layouts, and finally apply filters to visually distinguish the system. Make sure you have the dataset WFPRME09 Systems A open and refer to drawing RME0901 as needed. Part 1. Component Placement, Steps 1 to 6. Step 1. Start by opening the file WFPRME09 Systems A. Step 2. Navigate to the ground floor plan and zoom into the area between grids F2 and E3. Step 3. On the Systems tab, go to the HVAC panel and choose Air Terminal. From the Type selector, pick the terminal type: Supply Diffuser, Rectangular Face, Round Neck, 600 by 600 with 200 neck. Step 4. Set Properties. Before placing the terminal, set these properties: Level, Plenum 00, Offset 0.0, Total Pressure 21 pascals, Flow 135 liters per second. If the first diffuser ends up hosted on the wrong level, delete it, copy the corrected one, and continue. Step 5. Place 6 diffusers in the room, spaced at 3,600 centers. Part 2. Creating the system. Steps 7 to 17. Step 7. With the diffuser selected, go to the Modify Air Terminals tab, open the Create Systems panel and choose Duct. Steps 8 to 9. This opens the Create Duct System dialog. Set the system type to Supply Air and name the system Mechanical Supply Air Room 2. Click OK. Step 10. Press OK again to close the dialog. Two ways to build the system. At this stage, you can use Edit System to manually add the remaining diffusers and equipment, or use Select Equipment to choose the fan coil unit first. Step 11. Select the first diffuser again to continue assembling the system. Step 12. From System Tools, click Select Equipment and choose the Fan Coil Unit, FCU. Revit highlights both the diffuser and the FCU with a blue outline. Step 13. With the FCU selected, confirm that the system now recognizes both the diffuser and the equipment as part of the system layout. Step 17. Next, open the 3D view labeled System 3D to review the components in 3 dimensions. Use the Home View button if needed. Part 3. Generating the duct layout, steps 18 to 27. Step 18. Select any diffuser again, and in the Layout panel, choose Generate Layout. Step 19. Revit will now generate multiple layout solutions. If other systems were already in the model, you would be able to merge or attach to them via the options bar. Step 20. Click Settings in the options bar to configure duct connection types. Step 21. Main and branch duct types. In the duct conversion settings dialog, set main duct type equals rectangular duct, flange square bend or T, set branch duct type equals same value, set both offsets to 700.4 mm, which aligns the center of the FCU connectors with the duct center line. Step 22. Confirm both offsets are 700.4 mm. Step 23. Click OK to close the settings. Step 24. Scroll through the different solution types that Revit generates. Step 25. Select solution type 1 of 5. Step 26. Click Finish Layout to finalize the duct routing. Revit now creates ducts, fittings, and branches according to the chosen configuration. Step 27. Warnings appearing. Revit now displays a warning stating that 1 out of 3 elements has an open connection. This isn't an error, but it does affect flow calculations. We will learn how to resolve these issues properly in Module 12 during the Detailed Duct Systems module. Step 28. Return to the ground floor plan. Step 29. Open the Visibility/Graphics Overrides dialog by pressing VV. Step 30. Go to the Filters tab and select Add. Step 31. From the Add Filters dialog, choose Mechanical, Supply and click OK. Step 32. Override the pattern color to RGB0. 191, 225, a bright blue color. Step 33, click OK to confirm the color override. Step 34, change the pattern itself to solid fill. Step 35, confirm all settings and close the dialog. The entire mechanical supply system now displays in blue, making it visually distinct. This technique makes system checking, coordination, and output production significantly easier. This completes the Module 9 exercise. We've placed air terminals, added equipment, created a mechanical supply air system, generated a duct layout, resolved Revit's system warnings, and finally applied a filter to visually differentiate the system. In the next modules, we will explore duct systems in greater detail, including transitions, loss coefficients, and proper connector-based modeling technique. Please like and subscribe to the channel. I'll see you on Module 10.